Welcome back to Balvikan Bharti. Actually, after so many days, I've got a comfortable Wi-Fi connections. I'm living somewhere where this Wi-Fi connection is very hard to get, but somehow with some source I got this. But the videos I will make it's not much comfortable as earlier. So to continue with, I will keep my space very slow so that I should not cover more important subject that has to be very clearly and very comfortably made and can be reached to the viewers. Just to keep my viewers attached to this channel, I try to make these videos. So bear with me. With this note, I will not stretch it further. So that we have already started solving problem on probability. The next problem that will come is number 15. It is very straightforward. If the probability of an event is given as 0.05, what is the probability of not happening that event? So as you know, the probability of happening an event plus the probability of not happening of that event, you can put it in with the notation of E dash, is all together is 1. So if you want to know the value of PE dash, then what you have to do, you have to minus it from the probability of that event from 1. So 1 minus the value is already given 0.05, that will come 0.95. So this will be your answer. Okay, I will move to the next. This says 12 defective pens are accidentally mixed with 132 good ones. It is not possible to judge by looking at the pens and tell whether or not it is defective. Okay, so one pen is being taken out randomly from all the mixed one, means 12 and 132 mixed pens. Determine the probability that a pen is taken is good. So the solution is that it is very simple. The probability as a result or as a formula, you can say that it is the number of favorable events or number of favorable results, you can say, and number of probable results. So this is the simple one. Now as you have mixed, so your number of results, if you pick one at a time, could be 112 plus 132. This is the number. So number of event, probable event is the number of the size of the space. Okay, sample space. So this is sample space 12 plus 132. A number of events where you are preferring that you will get a good pen. So the number of good pen is 132. Okay, so whatever you choose, so that would come as a good pen. The possibilities are 132 numbers. So out of that, if you pick, you will get definitely good. So this is your probability 132 by 144. Okay, this should be your answer. Moving to next. A coin is thrown 3 times. What is the probability that least head is obtained? So I suppose this kind of problem was shown, but still I am showing it because what I did in the last time, I have taken all the possible outcome for each cases where the coin is tossed 3 times. So if I toss for any instance, if I get all head, this is a one result, one outcome of all the combinations if I throw it thrice. So in this way you will get several results. But what I said last time also, if it is is very less in number, where you toss the number or toss a coin for a less number, then it is definitely will be very easy for to get the combinations. But if it is so many times, let's say 10 times, so then it is not possible to do this exercise. So rather, if I toss a coin, because I know the nature of a coin, if you toss once, you will get a probability of 2 results. And I said also, if the events are done such a way that you need the cumulative results, then it cause a and in between. That means tossing a coin first time and second time and third time. So that means you want to get the results for all those events, okay, not for one of the results. So when that and factor is coming, so the results will be the total probable result will be multiplied. So 2 for the first toss, 2 for the second toss, 2 for the third toss. So there is 8 probable result that may come, and out of that, now you need at least one head. So out of this 8 results, if one head at least comes, that is your win. That means you need one head. So the probability of getting one head is 1 out of 8 results. 8 combinations means each time I will get a result of 3, means a combination of 3. In this way, if I get somewhere where I will get only one edge, that will serve my purpose. So getting one edge is one only, okay. So this is the result you will getting, probability of getting one edge of head only, this is 1, okay. So in this case, there is the result, the probability of is 1 upon 8, okay. So this is your result actually. So if I elaborate it, you also can find that that at least one head is obtained. So at least one head, that means you are supposed to get at least one. So 2 and 3 head also can be counted well, okay. So in that case, if it is not that, so in this case, what would be the case where that will companion of these results? That means if at least one head is okay for you, so that means none of the result, if it is containing not even a single edge, will be the companion of that. So you know the happening of any event plus happening of not happen, probability of happening any event and probability of not happening that event is equal to 1. So instead of thinking on that way, that getting at least 1, that means 2 and 3 also possible, you can think the companion of that not getting any edge. So not getting any edge is possibility is 1 only, because not getting any edge each time either you get 8 or head or tail. So not getting any edge, that means all consecutive times you will get all tail. So that is the possibility, probability of getting not edge, that means you can put it h dash is equal to 1 upon 8. So that will be a result. But getting at least one edge, it is just a companion of this. So probability of getting no edge and probability of getting edge at least is 1. That is perfect. So probability of getting at least one age is 1 minus not getting any age, isn't it? So this is 1 minus 1 by 8, so that is 7 by 8. So your answer will be 7 by 8. That can be also explained in this way: H T then T, then you can leave it TH, and then 1 2 3 4 5 6, then what else? THT, THT I have already written, and HTH. So these are the 1 2 3 4 5 6 7 8. These are the combination possible. So out of that, you are not getting age is in one case only. So every case you are getting age, at least one age. So by this way also you will see the result comes your getting any age, except this case all 7 cases you are getting age. So this is also, this way also satisfied. Understood? Okay, coming to the next. The next is find the probability of getting a numbered card when the card is drawn from the pack of 52. So if you are well aware of the playing cards and their characteristics, so each there are 4 characteristics card. These are hearts, dice, spade, and clubs. So these are the 4 characteristics. Out of that, each characteristic having 13 cards. In that, so 4 into 13 are the number of cards. So these are the characteristic cards. Each characteristic cards also having 13 numbers, and these 13 numbers have 4 cards which have face, and remaining are number cards. Okay, so 4 if I leave, the remaining is 9. So 9 is number cards. So now if you know this classification of any playing cards, answering this question is very easy, because you need to know the basic of the you can say the design of the cards, playing cards. So 52. So what is your need? Find the probability of getting number card. So number card for each case is 9. Now this is not distinguished which characterized number card is you needed. So it is any characterized card is needed. So all total 9 into 4 will be the count for our number cards is 36. So 36 of my probable results, and my 30 is my favorable results, and probable result is 52. That's it. This will be my probability of getting any number cards. Okay, number cards is done. Next one is, there are 5 green and 7 red balls. Okay, fine. 2 balls are selected one by one, okay, without replacement. Okay, so there are 5 green and 7 balls kept in a bucket. 2 balls are selected one by one, randomly been selected. In this case, you have to assume that the person who is selecting is not seeing the color of the ball. Okay, so this has to be assumed, because if you see the ball and pick, you will pick as you wish. So there is no chance of randomness, means you cannot say it is a randomly been picked, if you can see. So when it is said randomly been picked, so you are not seeing the color of the ball, because there is no choice of getting. So find the probability that first is green and second is red. Okay, so I pick any number randomly and see the color later. Oh, this is green. Later on, this is green or red, whatever way. So getting green out of 5 is 5 only, and getting red out of 7 is 7. So what do we say? There are 12 balls. Okay, this is a combination of 5 plus 7. Now when you are picking a ball without saying, so for when you are picking the first ball, so that ball is being picked out of 12. So your probability of getting what green first, so green getting, your probability for green is favorable is 5, and your total this is favorable, this is total probable results. So this is the case when you need to get green first, so you have to take the green ball as a first probability and take the favorable results as 5 out of 12. Now once it is done, your number of ball has to reduce, because you have picked whatever you pick, whether it is green or red, you picked one. So the next one you will pick, you will not pick out of 12, you will pick out of 11. So in this case, what we are doing, the both results are being added together to get the final results. This is not or. You are picking first ball and the second ball, and cumulative result is such that you are getting green first and red second. So that means your results is cumulative for both the results. So it is coming as AND, first result and the second result. So first result's probability is this one. Second result you want to get red, that means 7 is the possibilities, because you have not picked red once, so you have picked green, and the later you want to get red, so red is already 7 is there, out of the probability of getting is 11, because you have already reduced one ball by taking. When you are picking, you are not aware what you are picking, but you have picked. So you have picked, that means you have already reduced the number. So the probability of the results outcome has to be chosen from the sample space. Your sample space has reduced one number. So this is the total probability of the fact when you will get one green, one red consecutively. First green, then red. This is the, so this is your 35 upon 12 into 11. It is 132. Okay. So this is the case. Okay, understand. So now if we go further in this, if the problem is says like that, you get 2 consecutive greens. So what would be your result then? 2 consecutive greens. First green, 5 out of 12. You already picked a green. It is well. So in second case, your sample space is reduced to 11. So in second case also, you want to pick green. So that means your chances of getting green is also reduced to 4, because you already picked green, that is confirmed. So your remaining green ball is also to be reduced by 1. So if it is consecutive green, then your result must be look like this. Understand the difference? Okay. So the last one for today is, one card is drawn at random from a pack of 32. Again is a card problem. First probability of getting honored card. So this is only the familiarization of the card. That's why I have just picked this problem. What is honored card? Honored cards are those which have their specific characteristic and being honored with the highest number. So this A, K, Q and Joker, these are honored card. Okay, this is being honored with some specific characteristic. Other cards are number cards, that the numbers are as counted as we count numerical numbers. So those are not very specific, but these are very specific. This is honored card, whereas the face card are those where some face will come. Out of this, A doesn't carry any face. King carries king face, Q carries queen's face, J carries Joker's face. So these are the face cards. This is only the you can say the knowledge that you must have to solve this problem. So now once you know this, the probability of getting honored card. So this again comes for each characteristic card. So there are 4 kind of characteristic card in total 52. So there is 4 into 4 number of favorable result for first case, and for second case your result will be 3 into 4. So this is 12. So this is the only thing you need to know. So then probability is 16 upon 52, here 12 upon 50. This will be the results. Okay, so I will end up here. I will try to do it in regular basis if time permits, or and the situation is favorable for me. I will try to upload the videos on a regular basis from onwards. Otherwise, maybe a discontinuity in between. Just I request viewers to bear with me. I'm just trying in this adverse circumstances, you can say. You don't know how I'm living right now. I'm just spending some time here, but I will move on to some other place, and then I will definitely do as I am doing earlier. Okay, so thank you for now, and good night.